A pleasant day to the grade 9 Socrates of the NUSP San Isidro Campus Laboratory High School. This day we'll be discussing the continuation of our lesson, which is the graphing of quadratic functions. So these are the objectives of today's lesson. Number 1 is graph quadratic equations. Number 2, identify the axis of symmetry, vertex, domain, range, and intercepts for a given parabola. By the way, the source of this PowerPoint presentation is the www.stbarnabasi.com. Quadratic function is being defined by y equals ax squared plus bx plus c, where ax squared is the quadratic term, bx is the linear term, and c is the constant term. What is linear term of y equals 4x squared minus 3? The answer is 0x. But if it is 0x, we don't write it anymore. What is the linear term of y equals x squared minus 5x? The answer is negative 5x. What is the constant term of y equals x squared minus 5x? The answer is 0. And if it is 0, we don't write it anymore. The question is it possible for the quadratic term to be 0 in a quadratic function? Yes or no? The answer is no. Because if the quadratic term became 0, that is not a quadratic function anymore. Instead, it's a linear function. Quadratic functions. The graph of a quadratic function is a parabola. A parabola can open up or down. If the parabola opens up, this one, the lowest point is called the vertex. So this is the vertex, which is the minimum because it is in the lowest point. While if the parabola opens down, the vertex is at the highest point, which is the maximum. Note that if the parabola opens left or right, it is not a function. So if the parabola opens to the left or opens to the right, it is not a function. Standard form. The standard form of a quadratic function is y equals ax squared plus bx plus c. Once again, where ax squared must not be equal to 0 because if a is equal to 0, the quadratic term will be 0. And if the quadratic term is equal to 0, that is not a quadratic function anymore. It is just a linear function. The parabola will open up when the a value is positive. So if a is a positive integer or if a is greater than 0, then the parabola will open up like this. And then if the parabola will open down, then the value of a is a negative 1 or a is less than 0. And take note that a must not be equal to 0. As I've said earlier, if a became equal to 0, then that's not a quadratic function anymore. Parabolas are symmetric. When do we say that it's symmetric? If we drew a line down the middle of the parabola, we could fold the parabola in half, meaning this side is symmetrical to this side, or this side is totally equal to this side. And this line is what we call the axis of symmetry. The axis of symmetry is a line that divides the parabola into two equal parts. If we graph one side of the parabola, we could reflect it over the axis of symmetry to graph the other side. Like that. So you can draw the parabola by just having the axis of symmetry and one side of the parabola. You just copy the other side. The axis of symmetry always passes through the vertex because the vertex is the middle of each parabola. That's the center of the parabola. So here's the video for you to watch application or real life situations where you can find parabola.
Whether you're watching Dr. J rock the cradle right in front of you, or when you're watching some fountains shooting through the air, both Dr. J's flight path and that of the water shooting through the air can be modeled by a quadratic equation. The shape itself is known as a parabola. Parabolas and quadratic equations have many real-world examples. Let's take this example that you're about to see. During the Battle of Gettysburg, Confederate forces were supposed to knock Union cannon off the top of the ridge. Let's move away from war. Let's start dealing with flight. And not quite the kind of flight that you would think. However, taking a look at the path at which these riders come out, they go up in the air, gravity kicks in, they got to come back down. Oh, by the way, I should probably say, don't do this at home, because, yeah, they're professionals. Not to mention the fact I'd really hate to get sued because you're like, dude, I saw this amazing thing about parabolas, and I had to go home and try it. So please don't do this at home. But watch the path. As this jumper goes through, it comes out to be a parabola. So the next time you're sitting there watching these guys jump through the air, sit there and think, what's the equation of that parabola that they're flying through the air at? Nah, don't do that. Then again, look here. You can see that we have parabolic shapes coming off as the light hits the wall from the light above. Even bananas are in the shape of parabolas. You can go through and create the quadratic function of a banana. I wonder if the minions do this before they eat them. Yeah, I have to ask them. Here we have just a satellite array. It will take in the signals from space, bounce it back to the little focus point that's on the top there. This is actually part of the world's largest array that's located in Chile. They send out signals and receive signals. You could have solar farms. Here's an example of a solar farm in a desert. There's a pipe that runs through the middle of that parabolic shape. The sun reflects off that, bounces back, heats up the pipe, creates energy. What an amazing concept. This is by far one of my favorites. When you have a plane that flies overhead, sound comes off in the shape of a cone. When the sound cone hits the ground, it creates a parabola. The intersection of a plane, meaning a flat surface, with the actual cone. Here you can really see the cone coming off of this F-14 as it flies by right above the water. I'm going to let you listen to the sound of a couple of these as they break the barrier. A perfect example of why you see the jets, then you hear them. So what about bridges? This particular one has a nice shape of a parabola. So does this one. When you look at the suspension cables of the Golden Gate Bridge, the shape looks like a parabola. Therefore, it could be modeled with a quadratic equation. Now, I could ask you to come up with the equation, but who's going to do that? Oh, wait a minute. I'm a math teacher. That's exactly what I would want you to do, and here's how it would look. Think you could do it? Seems rather easy enough if you know how to deal with quadratics. However, sometimes in all of our engineering feats, we don't quite get it right. Here's an example. Just sit back and...
Then the third longest suspension span that became known as Galloping Gertie as it swayed in the winds sweeping up Puget Sound. 4 months after it was opened, those winds sent the bridge into a rhythmic dance of death. It literally shook itself to pieces. Caught in the middle of the bridge was a Tacoma newspaperman. The bridge twists and sways in its death agony. Since its opening, engineers had studied ways to end its strange vibrations. They claimed to be on the threshold of success, but too late. The reporter, Leonard Coatsworth, manages to fight his way to safety. most of the way on his hands and knees. He abandoned his car with a pet dog inside, the only life lost in the disaster. The giant cables are under stupendous strain as the great roadway of the bridge whips about like some fluttering ribbon. These pictures have been acclaimed as some of the greatest ever filmed. Here it goes.
Well, thank you for taking some time to investigate parabolas with us and the underlying quadratic equation. Hope you enjoyed this little visual. Hopefully it energizes you to try to learn more about quadratics. Hopefully it doesn't make it just plain old paper, pencil, find the vertex, find the axis of symmetry, play connect the dots. Thank you and have a great day.
So there you go, the different real life structures of parabola, and I hope like the announcer in the video, that you'll be energized into learning quadratic function more. So these are the things that we need to have in graphing quadratic function. You need to have your graphing paper or the coordinate grid paper where we could have x and y axis, the table, and of course the equation of the quadratic function. So the first step is to find the axis of symmetry of the quadratic function. When a quadratic function is in standard form, y equals ax squared plus bx plus c, the equation of the axis of symmetry is simply x equals negative b over 2a. So for you to find the axis of symmetry, again, the axis of symmetry is the line that passes through the vertex of the parabola, which divides the parabola into two congruent parts. So the formula in solving for the axis of symmetry is negative b over 2a for a quadratic function. This is best read as the opposite of b divided by the quantity of 2 times a. Find the axis of symmetry for y equals 3x squared minus 18x plus 7. So we are going to solve for the axis of symmetry using this, x equals negative b over 2a. By the way, what is b here? In this quadratic function, b is negative 18 and our a is 3. So we need that values in solving for the axis of symmetry. So there you go, a is 3, then b is negative 18. Then using the this equation, we substitute the values. So you will have negative b, so negative 18. Negative of negative 18 will become positive 18 over 2 times a, which is 3. So that's 2 times 3 is 6. So you will have 18 over 6, which is equal to 3. So the axis of symmetry is 3. Find the vertex. Finding the vertex. So that is the first step in graphing the quadratic function. Find the axis of symmetry. Next, you find the vertex. The axis of symmetry always goes through the vertex. That's correct. Thus, the axis of symmetry gives us the x coordinate of the vertex. Of course, if you already have the value of the axis of symmetry, then you already have the x coordinate of the vertex. Find the vertex of y equals negative 2x squared plus 8x minus 3. The first step is to find the axis of symmetry. Okay? So using the formula x equals negative b over 2a. So you identify a and b. A is equal to negative 2 and b is equal to a. Then by substitution, you will have negative 8 over 2 times negative 2 is equal to negative 4. So negative 8 over negative 4 is equal to positive 2. So the axis of symmetry is equal to 2. So the x coordinate of the vertex is already 2. Then, after finding the x coordinate, so you already have the axis of symmetry, substitute that, yung 2, the 2 that we get upon solving for the axis of symmetry into all x's here. So we change this 2x's by 2. So you substitute, you will have 2, negative 2 times 2 squared plus 8 times 2 minus 3. Then simplifying it, you will have 2 squared, which is 4, and then 8 times 2 is 16. Then simplifying it further, you will have negative 2 times 4 is negative 8 plus 16 minus 3. So you will have 5, because negative 8 plus 16 is equal to 8 minus 3 is equal to 5. So the value of y is equal to 5. So our vertex now is 2, 5. So that is our vertex. So we already solved for the vertex. This 2 is the axis of symmetry, and this 5 is the value of y when we substitute the value of x, or the axis of symmetry, into the original equation for us to get the vertex. Again, the vertex is the center of the parabola. Graphing a quadratic function. So the 3 steps are, number 1, find the axis of symmetry using x equals negative b over 2a. Step 2 is to find the vertex. Then step 3 is find 2 other points and reflect them across the axis of symmetry. Then connect the 5 points with a smooth curve. Let us try. So let us make a table using x values close to the axis of symmetry, like what I presented you a while ago. So here's the grid with x and y axis. Find the axis of symmetry. What is the axis of symmetry? X equals negative b over 2a. Then by substitution, your b is negative 4. So negative of negative 4 will become positive 4. Then 2 times a, which is 2. So 2 times 2. Then 4 over 2 times 2 is 4. 4 divided by 4 is equal to 1. So the axis of symmetry here is equal to positive 1. We now move on to step 2. And then after finding the axis of symmetry, we draw the line here of the axis of symmetry, since we know that x equals 1. So here is a positive 1. This is the origin of the Cartesian plane. This is 0. Then here is 1, 2, 3, 4, the positive ones and the negative ones at the left. Then the positive on the top and negative at the bottom. So this is x equals 1. So definitely this is our axis of symmetry. So x equals 1. Then the next step is to find the vertex. We are going to use this value, the value of our x, substituting that value into the original equation. So you will have y equals 2 times 1 squared. There, minus 4 times 1 minus 1. And then simplifying it, you will have 1 squared is 1 times 2. So that's 2. Minus 4 times 1 is 4 minus 1. So you have 2 minus 4 is equal to negative 2. Minus 1 is negative 3. So our vertex is at 1, negative 3. There is 1, negative 3. So 1, then negative 1, negative 2, negative 3. Here is our vertex. And then the last step is to find 2 other points and reflect them across the axis of symmetry. Then connect the 5 points with a smooth curve. So in this case, let us choose 2 points at the right side. So how about we choose 2 and 3? So here is 1, so we choose 2 and 3 as the value of our x's. So let us solve for the value of y using the assigned values to x. By the way, you may also choose values at the left side of the axis of symmetry. You may choose negative 0 or negative 1. So it's up to you. By the way, you will just arrive at the same graph. So using the value of x which is equal to 2, we substitute that into the original equation. So you will have 2 times 2 squared minus 4 times 2 minus 1. So simplifying that, you will have 2 squared is 4 times 2 is 8 minus 8 is 0, so that is negative 1. So the value of y is negative 1 if x is 2. Yeah. So you write there. And then we solve for the other one, which is 3. So there is 2 negative 1. So we substitute 3, so you will have 2 times 3 squared minus 4 times 3 minus 1. So we change the value of x to get the value of y. So 3 squared is 9 times 2 is 18 minus 12. Since 4 times 3 is 12. So 18 minus 12 is 6. Minus 1 is equal to 5. So the value of y is 5 if x is 3. So that's 3, 5. Then we plot the point into the grid. So there is 3, 5. 1, 2, 3, then 5. 1, 2, 3, 4, 5. So there you go. We already have the right side of the parabola. So what we are going to do is to reflect them across the axis. Since this is the center, we reflect it. So we plot point into here, and then we reflect it 1, 2, then 1, 2. So there you go. We have 5 points already. Then what we are going to do is to connect this curve smoothly. There you go. So that's the graph of the quadratic function y equals 2x squared minus 4x minus 1. Y-intercept of a quadratic formula. Y-intercept meaning where does the parabola touches the y-axis. So in this quadratic function, y is equal to 2x squared minus 4x minus 1. Our y-intercept, there you go, the y-axis is the red line, and the parabola touches the y-axis at this point. So the y-intercept of a quadratic function can be found when x equals 0. So the same as in the linear function, you can solve for the y-axis or for the y-intercept if you set x equals to 0. So you will have this. You substitute x equals 0. So the remaining would be the constant term. Only the constant term, which is negative 1. So this is our y-intercept. It's at negative 1. That is the y-intercept. The constant term is always the y-intercept. So no need to compute like this. Just look into the equation. If it is in the standard form, then upon looking at the constant of the quadratic function, that is already the y-intercept of the quadratic function. So solving a quadratic function, the x-intercepts when y equals 0 of a quadratic function are the solutions to the related quadratic equation. That is the reason why during our last discussion, we discussed how to solve quadratic equations. So we have learned how to solve quadratic equations in different ways. We have the factoring, the square root property, completing the square, and the last one is the quadratic formula. So for you to determine the x-intercept of the quadratic function, you have to set y equals 0. So you will be having a quadratic equation. And then in that quadratic equation, what you are going to do is to solve for the values of x. So let's take a look at this example. So as you can see, the equation here is x squared minus 2x plus 5. So definitely, upon observation, this parabola do not touch the x-intercept or the x-axis of the Cartesian plane. So there is no solution here. We do not have an x-intercept. So for number 2, we only have one solution. So here one solution, x equals 3. Because it touches the x-axis at 3. So only once. And in this case, we have two solutions because it touches the x-axis at two different points. The first one is at -2 and the second one is at +2. Okay, so let us dig deeper into identifying solutions. Find the solutions of 2x minus x squared equals 0. So we may use factoring here, correct? So the solution of this quadratic equation can be found by looking at the graph of the function equals 2x minus x squared. This f of x meaning function of x or equal to 1. F of x or 1, they are just the same because y is a function of x. So here is the graph of this quadratic equation or this quadratic function. So we can already observe what is the x-intercept of this quadratic function or what are the solutions. So the x-intercept, the solutions of f of x equals 2x minus x squared are the solutions to 2x minus x squared equals 0. So there you go, that's at 0.00 and 2, 0. So meaning x is equal to 0 and x is also equal to 2. If you have any more questions with regards to what we discussed this day, please do not hesitate to send me a message in our group chat, Mathematics 9, Grade 9, Socrates. Thank you very much and God bless. Hope to see you soon.